All right, hey guys, welcome to day 2 of adding and subtracting. So yesterday, all of the denominators were the same for our fractions. So we were able to just add or subtract the top. The problem that we're gonna have today is the denominators of our fractions are going to be different. So what we're gonna have to do is get a common denominator first, and then from there, go ahead and do what we did yesterday. So first thing I want to bring you back to is kind of what it looks like when we were dealing with fractions in, elementary school or middle school when we were trying to add or subtract them. So let's say I had 1/3 and I was trying to add to it 6. What are we gonna do? 6 halves. Okay. Or let's just make it easier. Let's just do 1/2. Okay. Trying to add to it 1/2. The problem with this is you cannot put these together because they don't have a common denominator. So what we would do is we would think to ourselves, okay, what number do I have to make the denominator look like so that I can combine them together? Or what factor do 2 and 3 both go into that I can make it look like so that I can add them together? So what we ended up doing was we said, well, I'm going to multiply this side by the opposite number over there by 3, and whatever I do to the bottom, I have to the top. And then I'm also going to multiply this side by the opposite number over there, which is 2. Whatever I do to the bottom, I have to the top. So I ended up getting 2/6, and that was added to 3/6. So then I could add together, the denominator would stay the same, and I would say, well, I have 5/6 then. So we're going to use that same idea when we're finding a common denominator for our fractions today. So if I'm looking at finding a common denominator, I have x plus 2 over 2x minus 3 and 4 over x plus 3. I'm basically just going to look at what does the second fraction need in the bottom that the first fraction has. Well, the second fraction has an x plus 3. It needs a 2x minus 3. So I'm going to multiply this side by 2x minus 3. And then I'm going to do the same exact thing, only opposite. So what does the second fraction have that the first fraction needs in the denominator? Well, it needs an x plus 3. So I'd multiply this side by x plus 3. Just remember what you're doing then to the bottom, you also have to do to the top. So I would be multiplying the tops by those as well. So since all it's asking for in number 1 and 2 is the common denominator or the least common denominator, it's what would the bottom of the fraction look like? What do I need the bottom to look like? Well, I need it to look like x plus 3, 2x minus 3. That's what I need in the denominator of both of them so that I can combine these two fractions. So let's go ahead and look at number 2 here. This is a little bit trickier. Whenever you have something squared, you're going to have to factor it first. So I'm going to look at this one. I know that this has a GCF of 5x, so I'm going to take that out. So I'm going to have 5x out front, and I'd be left with x plus 3. If I factored the second fraction, I have x squared plus 6x plus 9. There's no GCF, so I'm just going to factor it straight into x plus 3, x plus 3. Okay, because I multiplied a 9, add to 6. So now here's my second fraction. The first fraction, the first denominator, has a 5x and an x plus 3. So the second one already has an x plus 3, but it's missing a 5x. So I need to multiply this thing by 5x. That's what it's missing. It would need to have a 5x. So what I would do to the bottom, I would also again do to the top. We're not worried about that for this part yet. I'm going to repeat the process now. So what does the second fraction have that the first one needs? Well, it has the 5x now. It has an x plus 3, but it needs one more x plus 3. Okay, I need them to be identical. And then again, I would do that to the top. Does not matter for this exact moment. But when I'm looking at this in the least common denominator, the thing I would need the denominator to look like would be 5x and then x plus 3, x plus 3. They would need to have 2 of them. All right, let's go ahead and look at this first example down here where we're actually going to simplify the rational expression, okay? So when we are going to subtract these two things, we need a common denominator first. So what we're looking for is what do we need the LCD or the least common denominator to look like. So we go ahead and we factor things that we can first. So in this situation, I can't factor either of them. So I'm going to look at that second fraction. I'm going to say, well, what does that second fraction need that the first one has? The first one has a 2x minus 3. So I need to multiply top and bottom by 2x minus 3. I'm going to repeat that same idea with what does the second fraction have that the first one needs? It needs an x plus 3. Whatever I do to the bottom, I need to do to the top. So that's going to tell me that on the top fraction, the first one, I'm going to have x plus 3, x plus 2, minus 4 on the second fraction, 2x minus 3. And that's all going to be over. Now my least common denominator, what I found at the bottom to be, was x plus 3, 2x minus 3. Okay, take a second, process that. So what we're going to do then is we are going to simplify the top so that we can refactor it and cross things off that are the same on top as they are on the bottom. So for that first part, we're going to go ahead and we're going to distribute it out, double distribution, FOIL, whichever way you want to look at that. But we talked about this. We're going to take the x and we're going to multiply it by both things. We're going to take the 3 and we're going to multiply it by both things. So I'm going to end with x squared plus 2x plus 3x plus 6. And then I'm going to distribute this negative 4 to everything. So be careful when you have that subtraction sign. That ends up turning that to a negative whatever that you have to distribute in, remember, just like yesterday. So I'm going to get negative 8x and positive 12. And that's all still going to be over the x plus 3, 2x minus 3. I don't want to redistribute that because then I'm just going to factor it back out again, and that's just going back and forth, and I don't want to do that. So let's simplify the top of this, combining our like terms. I have an x squared. Now I have a positive 2x, a positive 3x, and a negative 8x. So I'm going to get 5x minus 8x is going to give me a negative 3x. And then I have my plus 6, or positive 6 plus 12. So I'm going to get plus 18. And again, that's all still over x plus 3, 2x minus 3. So this is to the point we were at yesterday now where I'm going to try to factor the top and cross anything off that's the same on top as it is on the bottom. So I'm looking for two numbers that multiply to 18, but add or subtract to 6. Sorry, add or subtract to negative 3. So I'm going to factor the top into x minus 6, x plus 3. So when I look at that, I made the 6 the negative because the middle term is negative 3, so the bigger number needs to be the negative. And that's all going to be over x plus 3, 2x minus 3. So I can find my excluded values from here. So my EVs, remember they come from the denominator. X cannot equal a negative 3. And if I'm looking at that 2x minus 3, remember you would set it equal to 0. I'm going to do a little side work over here. So 2x minus 3 equals 0. I would add 3. So then I would go ahead and get 2x equals 3 divided by 2. So my EV would, x would be not equal to 3 halves. And then I can cross things off. So I have a positive 3 on top, positive 3 on the bottom. I'm going to be left with x minus 6 over 2x minus 3. So it's a long process, but from about this point on, it's the same exact thing as we did yesterday. We just have to get that common denominator first. Let's go ahead and look at number 4. So in this situation, both the denominators are factorable, so we want to do that first. Okay, and I know that they're both factorable because they both have x squareds with them. So for this one, I'm looking for two numbers that multiply to a negative 2, but add to a 1. So I'm going to get x plus 2, x minus 1. The right side, I'm looking for anything that multiplies to negative 1, adds or subtracts to 0. So I get x plus 1, x minus 1. So we have to figure out what does the second fraction need the first one has. Well, the first one has an x minus 1. The second one has that. The first one has an x plus 2. The second one doesn't have that. So I need to add in an x plus 2. Whatever I do to the bottom, I have to do to the top. Now we're going to repeat that same process. What does the second fraction have that the first one needs? Well, it has an x plus 2 now. It has an x minus 1, but it needs an x plus 1. Whatever we do to the bottom, we need to do to the top. So on the top, I'm going to have x plus 1, x plus 3, and then I have plus 2 times x plus 2. And that's now all going to be over my common denominator, which was x plus 1, x plus 2, x minus 1. So we're going to go ahead and we're going to double distribute this out. That's going to get me an x squared, a positive 3x, a positive 1x, and a positive 3. And then we're going to distribute the 2 out. So I'm going to get plus 2x plus 4. And that's all still over my common denominator. X plus 1, x plus 2, x minus 1. So we're going to combine our like terms. I have an x squared on top. I have a 3x, a 1x, and a 2x. So I get a 6x. And then I have a 3 plus 4, 7. And that's all going to be over x plus 1, x plus 2, x minus 1. So what I'm going to do then is I'm going to go ahead and I'm going to factor the top if I can. Well, I know two numbers that multiply to 7 add to 6. I actually can't do that, can I? Multiplying to 7, I could subtract to 6, but because these are both positive, I can't do. So I can't factor that at all. So I'm just going to go straight to getting my EVs then, my excluded values. X cannot be a plus or minus 1 or a negative 2. And then I would leave this as my answer. Let's look at number 5 here. If you're starting to see the process, feel free to just head to the assignment. Otherwise, keep watching the video, see if you can continue to process through the next 2 problems still. So I'm looking at the denominators. The first one I know I can factor because it's something x squared. So looking at 2 numbers that multiply to 25, add or subtract to 10. So I'm going to get x minus 5, x minus 5. Because they are multiplying to a positive, I know that both of them have to be positive or both of them have to be negative. And then the middle term will tell me what that sign is going to be. If I look at the bottom of the second one, they don't have an x squared, but they have a GCF. So it's going to be 2x minus 5. So let's go through this process. We're going to look at the second fraction at the denominator. We're going to say, well, what does that one have? Or what is that one missing that the first one has? It has an x minus 5, but the first one has 2x minus 5. So I need 2x minus 5s in the second one. I need them to look exactly the same. So repeat the process with the first. The first one is now just missing that 2 on the outside. So I need to multiply that by 2 and that by 2. So we're going to rewrite the top. I have 2x minus x minus 4, x minus 5. And that's all going to be over my common denominator, which is 2x minus 5, x minus 5. Now, here's something a little tricky. This has a negative 1 that you would need to distribute to the first one. What I'm going to do is I'm actually going to FOIL this out first and then distribute the negative 1. So I'm going to have 2x minus 1 times x squared. I'll get a negative 5x and a negative 4x. So that's going to give me a negative 9x. And then negative 4 times negative 5 is going to give me a positive 20. And that's all over my denominator. X minus 5, x minus 5. And now we have one more simplification of distributing this negative 1 to everything. So I'm going to get 2x minus x squared plus 9x minus 20 all over 2 times x minus 5, x minus 5. And then we can combine our like terms. So I have a negative x squared. I have a 2x and a 9x. So I'm going to get an 11x minus 20 over 2 times x minus 5, x minus 5. Okay, now a lot of that looks like busy work, and you could probably do a lot of that in your head. If you can't, write it all out. It's okay. There's nothing wrong with that. So I would want to try to factor the top. Here's the problem that I have with that. I always want my a value to be positive when I'm factoring. So what I'm going to do is I can divide everything by a negative 1. So I'm going to end up with x squared minus 11x plus 20. Okay, it just changes your sign on everything. So now that my a value is positive, I could try to factor. Is there anything that would multiply to a positive 20, add or subtract to 11? There is not. So I'm going to go ahead and I'm going to find EVs. So excluded values come from my denominator. Remember, the 2 isn't going to give me one. That's not a variable, so I don't get one from that. But I will get one from the x minus 5, so I'm going to get a positive 5. And since I can't factor, that's going to be my answer. Okay, last one here. Let's look at this problem. So for the first denominator, I get 5x plus 2. There is no GCF, and I can't factor that. So I'm just going to leave that like that. Second one, I can factor this out. I know that 25 and 4 are both perfect squares. So I can go straight into my 5x minus 2 and my 5x plus 2. So the second one has the x plus 2 that the first one has, the 5x plus 2. It's not missing anything. The first one is missing the 5x minus 2. So this one needs to be multiplied by 5x minus 2. But that second one doesn't need to be multiplied by anything. It has everything in the denominator. So I'm going to have 5x minus 2 times 3 plus 5x all over 5x minus 2, 5x plus 2. Now this is just distributive property. It's just written backwards. But I end up with 15x minus 6 plus 5x all over my denominator. And then I can simplify the top. I have 15x plus 5x, so I'm going to end up with 20x minus 6 over 5x plus 2, 5x minus 2. And I want to try to factor the top if I can. I can't factor because they're not x squared, but they do have a GCF. They both have a 2 in common. So I'm going to take a 2 out. I'm going to be left with 10x minus 3 over 5x plus 2, 5x minus 2. I'm not going to be able to cross anything off, but I do still have to get those EVs, those excluded values. X cannot be equal to, remember, I would set that equal to 0 and solve. I'm going to get a positive and a negative 2/5. So I know this one looks hard, it looks frustrating, it looks confusing. I want you to try some things on your own, and then we can go over any questions that you have on Monday.